And good day, pre-algebra. We are going over CO44, starting off try 3, talking about another type of probability. You didn't even know this many types of probability existed, did you? But today we're focusing on mutually exclusive and overlapping events. Okay, mutually exclusive and overlapping events. And you've actually done something like this before. If we go all the way back to CO40, there's a question on there that I said, this is kind of a preview of something coming up. And let's see, right here, okay? This is from PO40, where we first learned about probability in general. And there were two questions on here. What is the probability of choosing a letter A through N or S through Z? And then one after that, what is the probability of choosing any letter in the phrase SVDP Royals? Okay. Now, this one, and actually every other probability question on this page, is an example of mutually exclusive probability. Okay. And this SVDP Royals one is an example of overlapping events. It's a little bit easier to see, probably, with the overlapping events there. Why do you think we would call that an overlapping event? To find the probability of a letter in the phrase SVDP Royals. Yeah.
Because there's two S's.
Right. Because one of those positive outcomes, an S, shows up twice. So if you remember, when we talked about this, what was the probability of picking a letter in SVDP Royals? What do you have written down?
Wait, what was the question?
How many successful outcomes were there in this situation? Choosing a letter from SVDP Royals.
9.
9. Okay, you may have had 10 and you may have had it crossed out, right? Because there are 10 letters here, but that S overlapping, we don't want to count that successful outcome twice. So there are actually 9 successful outcomes out of 26 possible because there are 26 letters in the alphabet. Okay, so overlapping events are situations where you have successful outcomes in common, right? That S shows up twice. It overlaps, and you would not want to count that as 10 out of 26 because there aren't 10 successful outcomes. There are only 9. Just so happens one of them shows up twice. Okay. Whereas mutually exclusive, A through N and S through Z, are there any overlaps there? No. Okay. There are no common outcomes there with mutually exclusive. So all the way back to CO44 and writing in these definitions, mutually exclusive events are events with no common outcomes. Events with no common outcomes. And an example is like virtually every other probability question you've had up to this point. There are 3 red, 5 blue, 8 yellow marbles in a bag. What is the probability of choosing a yellow or a red marble? Right? Even though there are 8 yellow ones, right? There's still individual outcomes. Okay, it's not like that S example where there is only one S in the alphabet and that one S showed up twice. There are 8 yellow marbles in the bag. So each of them is a distinct outcome here. What would the probability of this be? The probability of choosing a yellow or a red marble. What's the probability? How many successful outcomes are there? How many red or yellow marbles are there? Yeah.
11.
There are 11, right? 11 successful outcomes out of how many marbles are in the bag?
16.
16. So you have an 11 out of 16 chance of choosing a yellow or a red one. Okay? You don't have to worry about any overlapping events because yellow and red, they're different sets. A marble is not both yellow and red, it's yellow or red, right? Nothing overlaps, nothing is in common. Overlapping events are events with common outcomes. Okay? Overlapping events are events with common outcomes, like that double S and SVDP Royals. Another example, an integer is randomly selected from the numbers 1 through 20. What is the probability that it will be either odd or a prime number? What outcomes are in common? Well, let's write out all the integers from 1 to 20 here. Uh-oh, I didn't space this out very well. I gotta tighten it up. 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? And we're going to underline the odd numbers in red, right? Because we're looking for the probability of selecting an odd or a prime number. So odd numbers are successful outcomes. What are the odd numbers here? Who can? I'm throwing you a softball. What are the odd numbers here? Nolan?
1, 3, 5, 7, 9, 11, 13, 15, 17, and 19.
Good, right? Every other. Okay? So all the numbers underlined in red are successful outcomes because they are all odd. Right? But we're also looking for getting an odd or a prime number. What are the prime numbers here? I'll underline these in blue. What's the first prime? Anthony.
1.
1's actually not prime. Why is 1 not a prime number? Nolan?
Doesn't it have to be like something you can times something by?
Well, so most people think of a prime number as its only factors are 1 and itself. But therein kind of lies the reason why 1 is not prime. Its only factors are 1 and itself. What are the factors of 1?
1.
1 and
1.
1, right? It only has one factor. Okay? Only itself. So it doesn't quite fit the definition of having two distinct factors, itself and 1. So 1 is actually not considered a prime. So what is the smallest prime number, Anthony? 2.
Oh, no, I was doing 3.
No, 2 is correct.
Oh, what?
Because its only factors are itself and 1. Right? The only way to get 2 is to multiply 2 and 1 together. So 2, here's a little fun fact for you. 2 is actually the only even prime. All other prime numbers are odd. Okay? So 3 is prime. Only way to get 3 is 3 times 1. What's the next prime? 5 is prime. Only way to get 5 is 5 times 1. What's the next prime? 7. Next one? 11, right? 9's not, because 3 times 3 can also get you to 9. So 9 is not prime. After 11, 13, and then 17, and then 19. Right? So if I were to count up all of my lines, right, which my red and blue lines together represent my successful outcomes, if I counted all of these up, I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Is my probability of picking an odd or a prime number 18 out of 20? No, because if I have 18 successful outcomes and 20 possible outcomes, how many unsuccessful outcomes would that mean I have? Just 2. But there are certainly more than 2 non-underlined numbers here, right? All the even ones except for 2. So here's an example of overlapping events, right? All of these numbers here that have the red and the blue line, I can only count one time, okay? So I count 1 one time because it's odd, 2 one time because it's prime, 3 only one time because we don't want it to overlap. We don't want to count that 3 twice. There is only 1 3 between 1 and 20. Okay, even though it counts in both sets, we only want to count it one time. So In reality, I only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 successful outcomes here. 11 numbers between 1 and 20 are odd or prime. And if I have 11 successful outcomes and 20 possible outcomes, how many unsuccessful outcomes does that mean I have?
9.
9. Let's just check. Don't want to use blue. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Okay. So the idea behind overlapping events is you've got to be careful not to count an overlapping event twice. Fair enough? Questions? Comments, concerns, complaints, comments, congratulations, criticisms? Okay, very well. Let's look at some examples here. So it says, write whether the event is mutually exclusive or overlapping, then find the probability in fraction form. Oh, this looks familiar. You've got 26 cards, each labeled a different letter of the alphabet. What is the probability of you choosing a letter in the words S, V, D, P, or Royals? Do I have any overlapping events?
Yes.
Yes. So this is overlapping. We'll start by writing that. And why is it overlapping? What overlaps? The S. Okay. So I'm only going to cross out one of them, right? I still want to count that first S because it is still a successful outcome, but not the second one. Okay. So like we've already talked about, that leaves us with 9 successful outcomes out of 26 possible. If we count that second S, we'd have 10 successful, but 2 of them overlap. Don't want to count them twice, so only have 9. From the numbers 1 through 50, what is the probability of choosing a factor of 48? Mutually exclusive or overlapping?
Exclusive.
Exclusive. Okay, exclusive. Usually when you only have one thing to think about, then it's going to be a mutually exclusive. It's when you have this word or in here that you've got to be careful, right? In the top one, it was yellow or red. It did turn out to be mutually exclusive. And we talk about why, because each marble is individual. But then in the other example, prime or odd, that was an overlapping. Here, S, V, D, P, or Royals, we have that extra S, right? This one, we're only talking about really one set, just a factor of 48. What are the factors of 40? Or what are the factors of 50? Sorry, what are the factors of 48? Yeah.
2.
2 is a factor of 48. What does 2 pair up with? What's its factor, buddy? 24. Okay. What's another factor pair?
6 times 8.
6 times what?
8.
6 times 8. Okay, there's a factor pair. What else?
1 and 48.
1 and 48. That's a factor pair. There are 2 others.
16 and 3.
3 and 16. And lastly?
12 and 4.
4 and 12. No repeats here, right? We've listed all the factors of 48. Nothing repeats. How many successful outcomes do we have? Well, we can count up the factors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 successful outcomes out of a possible 50 numbers. So 10 out of 50 is our answer. From a standard 52-card deck, what is the probability of choosing a red card or a heart? There's that word or, so we've got to be a little careful here. Are there any overlapping events? Are there any common outcomes between choosing a red card and a heart? Think about that deck of cards that we used before. Anytime you've played a deck of cards. All of them, right? All hearts are red cards. Okay? So if our probability is choosing a red card or a heart, first of all, how many red cards are there in a 52-card deck?
52.
No. That's the total number of cards. Anthony?
What? Oh, I didn't raise my hand.
I know, but you kind of...
No, I didn't clear my throat. Yeah.
How many red cards are in a deck of cards?
8.
Sorry?
8.
More than 8?
10.
More than 10.
12.
Keep going.
14.
Raise it up.
16.
Higher.
18.
More.
20.
More.
22.
More.
24.
More.
28. Or 26.
26. Okay, half of them, right? Half the cards are red, half the cards are black. So in a 52 card deck, there are 26 red cards. All of those red cards, okay, well, I should say are hearts, but a heart, all of the hearts are red. So we don't need to include this at all because every single heart is already included in our 26 red cards. Okay, so the probability is 26 out of 52. It's overlapping because of all those hearts being red. So, questions on this? Okay, I want you to work on the rest of the page. You got 12 minutes here, which means I can definitely help you. You should be able to get through most of this before class is on. I don't want to erase this, so I'm going to just scroll down and read what we have here. You roll a 12-sided die. What is the probability of rolling an even number or a multiple of 3? There's the word or, so be careful. Check those overlapping outcomes. Are there any even numbers that are also multiples of 3? If they are, it's overlapping. You don't want to count those outcomes twice. In your class, what is the probability you choose a student with the last name that begins with a vowel? Okay. Is that usually exclusive, or are there overlapping events? And finally, that's it. So two questions for homework for tomorrow, 12 minutes to work. My math tells me it's an average of 6 minutes per question. Folks, if we don't play the number game tomorrow, catastrophic. Catastrophic.
Especially on Pi Day.
Especially, well, the day after Pi Day. Not doing your homework today, though, on Pi Day, just as bad. Okay? All right, I'm here to help. Your neighbors can help also. Make sure you write whether it's mutually exclusive or overlapping, then the probability in fraction form.
Yeah.
That's how you math.